In this video, we are going to learn a very important topic which we call or refer as sequences. So in order to have an idea of what sequence is, we look at these examples, and from there we will understand better what we mean by sequences. Now, the example says, in each of the following numbers, find the next two terms and state the rule that generates the terms. So you have a term like this. So the first one, the A part, you have a set of numbers like this. It has 1, 3, 5, 7, 9, and it continues in that order. So what will be the next number after 9? Then what also will be the following number? That's the question. We need to fill these boxes. So what will be the next number? And the question says, when we have obtained that, we now give the rule that actually states how we got them. You just study the sequence and you see that here, if you add 2 to 1, you get 3. If you add 2 to this 3, you get 5. You add 2 here, you get 7. You add 2 here, you get 9. So it's just an addition of 2. So therefore, to get the next one that will be in this box is 11. Then you add 2 again, this should be 13. So that's what is happening. So the rule that guides is simply add 2. So you add 2, or you add plus 2. So we add 2 to the preceding, either you call the preceding term. Please, let's get clear. What do we mean by terms? So when you talk about terms, the elements of this set now is what we refer as the terms. Okay? So this 1, 3, 5, 7 are the terms of these numbers. So now the rule says to get them, how do you generate? You add 2. You add 2 to the preceding term. So the first term, you add 2 to it to get the second term. Add 2 to the second term to get the third term. And that's how it continues. And that's how it is gotten. Okay. So look at the B part. The B part says you have a number like this. You have 2, you have 4, you have 6, you have 8, you have 10, and so on. So this one are easy to observe that here is the same addition of 2's. So here I have add 2, add 2, add 2, add 2. So now to get the other one, the one that will be in this box, is simply add 2 to here, you have 12. To the other one, you add 2 again to get 14, and so on. So the rule is the same. So the rule is still you add plus 2 to the preceding term. So that's the rule. Then let's look at the C part and see what is happening. So C part, you have a set of numbers of this form: 1, 3, 9, 2, 7, 8, 1, and so on. So we need to get actually the next two terms. So what will be inside this box? What should be inside this box before it continues? So you have to study the sequence and see how it is behaving. So you look at here, this is 1. So this is 1, this is 3, this is 9. So this 9 looks like 3 times 3, 9. You look at 27, look at 3 times 9, 27, 3 times 27, 81. You see that you are multiplying each term by 3. So you multiply the preceding term by 3 to get the next term. So if you multiply here by 1 by 3 will give you 3. 3 by 3 gives you 9. 9 by 3 gives you 27. 27 by 3 gives you 81. So in order to get the next term, you multiply 81 by 3. So if you multiply 81 by 3, so this gives you 3. 3 times this gives us 243. Then the next one, to get the next term, you multiply 243 by 9. So this will require a bigger box. So if you multiply by 3, so this is 9. This is 12. 3 times 2 is 4 plus 1. So this is 529. So this is 529, and so on. So you multiply each term by 3. So the rule, what is the rule? The rule that gets the sequence says you multiply the preceding term. You multiply the preceding term by 3. That's what is happening. So that's the rule. Then there are many of them. Look at the D part now. We look at the D part and see if we can understand the behavior of that set of numbers. So the D part says you have starting with minus 10, minus 9, minus 7, minus 4, 0, 5, 11, 18. So we need to get the next term here. Get the next term here. That's the next two terms. So how do we do that? So we have to look at the sequence and see how it behaves. So here you have, this is minus 10, minus 9. Okay. So it's just like you added 1 here. I don't know, but at least that's what happens between them. Then if you look at minus 9 to minus 7, you see it's like you added 2. Then minus 7 to minus 4, you see I added 3. You see what is happening? So you see here, you added plus 1 to get minus 9. You add plus 2 to get minus 7. You add plus 3 to get minus 4. You add plus 4 here to get 0. You add plus 4 to 0 to get 5. Then you add plus 6 to 5 to get 11. Then you add plus 7 to 11 to get 18. Therefore, to get the next one, you add 8. So if you add 8 to 18, that will give us 26. Then the next thing to add is 9. If you add 9 to 26, that will give us 35. You see 35. So how do we state the rule that guides this? Let's look at the way it happens. We say starting. So you starting from this first term, that is starting from minus 10, you add 1 to get minus 9. Then you add plus 2 to minus 9 to get minus 7, and so on. Okay, so in other words, just simply add 1, 2, 3 in turn, and so on. That's simply the rule. Okay, so let's look at the E part and see if we can understand what is happening in E. So E is here. So the E part, we have 0, 1, 1, 2, 3, 5. So we need to get the next one. We need to get the next one, and so on. So what can we say now? So let's look at here. You have 0 plus 1, 1. Here you have 1 plus 1 to give us 2. Here you have 1 plus 2 to give us 3. Here you have 2 plus 3 to give us 5. It's like we are adding them. So now to get the next one, you simply add 3 and 5. So if you add 3 and 5 to give us 8. Then to get the next one, you add 5 and 8. That will give us 13. Okay, so that's what is happening, and so on. Then let's see if we can interpret this, if you can give the rule that does that. So what we can say is that, you see that I started getting already, if you look at this sequence, you see that you have 0, you have 1. Okay, so it is 0 and 1 that I added. I added this 0 and 1 in order to get 1. Then I now added 1 and 1 to get 2. So what I'm trying to say actually is that the first two terms must be given in order for you to get the other terms. Okay, so that's what is happening. So what we now say, can say that apart from the first two terms, you add first two terms, add the preceding two terms. Add the preceding two terms. So you add the preceding two terms to get the next term. So that's how it works. Now, let us summarize what we have done so far. You see now, these are sets of numbers, these are set of numbers, these are set of numbers, these are set of numbers. But there is something unique in each of them. In each set of numbers, they behave orderly. They are oddly arranged, in the sense that for you to get the next term, there is something you will do to get the next term. So you do something that is specific, or that something that is fixed. So there is a particular way of getting each of the terms. There is a method that can be used to get each of the terms. So these terms are arranged in order. So such terms or such numbers or such set of numbers is what we call a sequence. So each of these sets are sequences, they are sequences of numbers because they are orderly arranged. So for you to get the next term, there is something you would do to get the next term. So there is a formula, there is a method that generates each term of that number. So such kind of set of numbers that has that kind of arrangement is what we refer as the sequences of a number, or rather what we call sequences. Then there's another thing about sequence which we should talk about now. So in sequence, in most cases, like I said, a sequence, you see, it has an orderly arrangement. So numbers that have that kind of orderly arrangement is sequence. Now, some sequences has a method, a formula that can generate any given term. That is, for you to find any term, the end term, you can always find it. Let's look at this. If you look at this, these are odd numbers. 1, 3, 5, 7, and so on. These are odd numbers. So there's a way, a method you can generate the odd number. 2n minus 1 will generate this. So you see that is equals to 2n minus 1. This gives you the formula that generates this. What does this formula give? Now, this one is the first term, right? This is the second term of this sequence. This is the third term of this sequence. This is the fourth term of this sequence. So this is the first term. This is the second term. This is the third term. This is the fourth term. You see. Now, if I want to get the fifth term, I'll add 2, right? But supposing somebody tells me what will be the 100th term, you see that it's difficult. I cannot keep on adding, listing the number, listen until I get the 100th term. It will be too cumbersome for me. So in that case, you can use the formula. So this formula is what we call the general term. Then you call it the general term of the sequence. Or what we should see later, we can call the nth term of the sequence. So now for me to get the 100th term means that my n is 100. So if you put n equals to 100, in this formula I have 2 times 100 minus 1. So 2 times 100 minus 1, this is 200 minus 1. This will give you 99. Then again, you will also see that apart from getting that, you see that this formula will generate every terms of this sequence. So let's look at that. If n is equals to 1, if n is equals to 1, what do I have? 2 times 1 minus 1. So 2 times 1 is 2, and 2 minus 1 is 1. So that corresponds to the first term. When n is equals to 2, I have 2 times 2 minus 1. This will give me 4 minus 1, which is equals to 3. This corresponds to this term. For me to get the third term, it means that n is equals to 3. So when n is equals to 3, you see n is equals to 3. So this gives me by formula 2 times n, which is 2 times 3 minus 1. This will give me 6 minus 1, which is 5. You have your 5. The fourth term means when n is equals to 4. So if you put it in this formula, it becomes 2 times 4 minus 1, which is 8 minus 1, which is 7. It gives you this. So that's what it does. So a sequence has a general term. A general term is a formula that gives you all the terms of the sequence. So any given term you want, you plug it into the formula and you will get it. So that's the beauty of a sequence. And that formula that does that is what we call, either you call it the general term or you call it the end term of the sequence, which we shall have the full discussion on it in the subsequent videos.